All right. Hi. So today, I had a couple students talk to me about inverse operations, right? Specifically, how to do it in the process. And so, before I wanted to get into inverse operations, I kind of wanted to explain how I try to um, make inverse operations seem like something that we do in real life, because it is something that we do all the time. And the way is like this. So, my question to you guys is, what do you guys do when you lose something, right? So let's pretend, for example, you got, home from school, you lost your shoe. It's the next day, you lost your shoe. Your mom's screaming at you, like, hurry up, let's find it. What are you doing in your head to find it? Now, most of you guys are going to say, retraced your steps, right? You are going to be like, well, the last place I had it was here. I did A, B, and C since I last had it. And so what I'm going to do is I'm going to basically retrace my steps, undo everything I did that day, and then find the last place I had it, right? So let's say, for example, you got home, school lunch was trash, so you're like, let me try to get something right here. You were starving, so you start eating up, right? You took your shoes off under the table for some reason. You ran upstairs, played games with your friends, blah, 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 fell asleep, woke up. Now, all of a sudden, the next day, you're starting to remember that. You're like, okay, I do remember eating. I remember running upstairs. I didn't have my shoes on when I was running upstairs, so that means that my shoes are under the table. Math, we have the same exact thing. So our x value is a missing number value. In this case, this is our lost shoe right here. And what we need to do is we need to retrace our steps and basically undo everything that's happened since we lost our shoe, which is the numbers on the same side of the equation right now. In this case, the plus 5 is going to be one of those things that we've done, right? So how do I undo adding 5? Subtracting, right? So in this case here, I'm going to subtract 5. Subtract 5. Like that. Okay. Now, again, this is an equation, meaning that these things have to be equal to each other. So I can't just subtract 5 on one side, right? That also means I have to subtract 5 on the other side. So I'm going to do that over here as well. Okay. Now 5 minus 5, these cancel out, so that's just going to be equal to x. And then 10 minus 5, that equals 5. Now, how do I know if my answer is right or not? Well, x equals 5. That means that x and 5 are physically the same thing. So what I can do is I can go back to this equation, right? Let me just delete all this. I can go back into this equation right here, and I can replace the 5, or the x with the 5. So now I have 5 plus 5 equals 10. Does 5 plus 5 equal 10? Yes. So that means that the answer is in fact correct. Okay, same thing on this one now. Okay, 2 steps this time though, because we have 2 things that we've done since we've lost the x. We have added 7 and we've multiplied by 2. Now, we can deal with the 2 first, and I can divide everything by 2. The only issue with dividing first though is you have to divide it by every single term, right? I have to divide this by 2, this by 2, and this by 2. That seems like a lot of work. It's a lot simpler for me to just subtract the 7, because I only have to just subtract the 7 once from both sides. The second I subtract the 7, it's gone, right? So that's all I have to do. So I'm going to subtract 7 from both sides. Here, 2x is equal to 10 now. I'm going to divide by 2 on both sides here. And now x is equal to 10 divided by 2, which is 5. Now, why did I do division? Well, anytime there's a number next to a variable like this, without any operation shown in between, it's assumed to be multiplication. So the opposite is division. 2 divided by 2 is 1. 1 times x is x, which is why this ends up just being x. And then 10 divided by 2 is 5. Again, we can plug this number back in right here. Okay, so 2 times 5, that's 10. 10 plus 7 equals 17. So far, so good. Okay. Now it looks like I have 3 times x plus 4 divided by 3 equals 9. Okay, a few more steps here. So what I'm going to do actually for this one is I'm going to rewrite this equation just so you can see what it looks like normally without it being in text form. So right now I'm looking at 3 different numbers that I have to get rid of. Now, there's a few ways that we can solve this, right? When it comes to inverse operations, there's a lot of ways to solve it. So if I do something that you wouldn't do, that doesn't mean necessarily that it's wrong. One thing that some of you guys might see is the fact that we're multiplying by 3 and dividing by 3. 3 divided by 3 is 1. And so this basically cancels itself out here. But for the sake of this situation, since we're trying to really learn inverse operations, I'm going to deal with all of these separately. What I'm going to deal with first is the 3 on the bottom. Why? Because technically everything up here is divided by 3. So this is technically not an x. This is an x that's multiplied by 3 and divided by 3, which ends up being x. But you get the point. It's not technically x. There's still this division sign here. Let's actually change this just for this case, just to kind of show you. Let me think of a number now that works. What did I have here originally? Just give me a second. Let's just change it to 2. It's okay if it's a fraction. So now 2 times x is 2x divided by 3 is 2/3 x, right? So this is technically not an x, it's 2/3 x. So I cannot simply just, for example, subtract this 4, for example. I can't simply subtract this 4 because it still has to be multiplied by 2 and divided by 3. So what I'm going to do here is I'm going to multiply both sides times 3 to get rid of that 3 first. Okay, that gives me 2 divided by x plus 4 is equal to 27. All right. Now, there's a couple ways that we can even deal with it from here. For one, we can distribute. 2 times x is 2x and 2 times 4 is 8. That is something that we can do. Or we can, again, understand that this is multiplication. This is 2 times x. So inverse operations allows me actually to divide the whole thing by 2, which is going to give me x plus 4 is equal to 27 halves. And then last but not least, I'm going to have to subtract by 4 on both sides. Now, when you're subtracting with fractions, we have to have a common denominator, so I'm going to put it over 2. The 4 is going to increase to an 8 because I multiply the top and the bottom by 2 because it's my smart version of 1. Okay, 27 minus 8 is 19. So I have 19 over 2. And again, math likes everything to be pretty, so what's the pretty version of fractions is a mixed number. 2 goes into 19, 9 times with 1 remaining. So 9 1/2 would be our final answer. Last one here, a little bit tricky. We have 3x squared minus 8 is equal to 40. Okay, so the first part, we have to get rid of this minus 8. How do I undo subtracting 8? I'm going to add 8 to both sides. That's going to give me 3x squared is equal to 48. From here, what I'm going to do is I'm going to divide both sides by 3. That gives me x squared is equal to 16. Cool way to do this in your head if division is a little bit hard for you. 3 goes into 4 one time with 1 remaining, so I carry the 1. 3 goes into 18 6 times. That's how I got 16. And now I have to take, what's the opposite of squaring? So in math, there's always an opposite of every operation. So addition has subtraction, multiplication has division, because we need the pencil side of a pencil, and we also need the eraser, right? We need to undo things. So the opposite of squaring is taking the square root. So I'm going to take the square root of both sides. The square root of x squared is x. Again, if you square something and then you take the square root, it just essentially undoes itself. And then the answer here is positive or negative 4. And for those who don't know, I'll give you a second to think about why is it positive or negative 4. Okay. The reason why it's positive or negative 4 is because let's plug in the values back. Remember, anytime you want to check to see if your answer works, plug in your answers, and if you get the same thing on both sides of the equation, it's correct. So let's plug it in right here. X squared equals 16. Well, what's 4 squared? 4 times 4. 4 times 4 is 16. Fair. But what about negative 4 squared? Well, negative 4 times negative 4 is also 16, right? A negative times a negative is a positive. So when it comes to inverse operations with square values, anything that's an even exponent actually, it's always going to have two answers, positive or negative, because of a negative times a negative equaling a positive. Perfect. And that's it for today. Hope you guys enjoyed. I'll see you guys on the next one.